Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. Welcome to Lady Khadija radiallahu anha online college. This is a live lesson for A-level maths year 2 pure maths. Today's chapter is parametric equations, and we're looking at a word problem that we started in the last lesson. Let's go into it. Bismillah ar-Rahman ar-Rahim. So this one is talking about a plane, and we have the two parametric equations describing the plane's motion after takeoff. Is the x equation is v initial velocity times cos theta times t, which is the number of seconds after takeoff, and then the y is given by the equation y is equal to v sine theta times t. We're also given that the initial speed is 50, so we can say v initially is 50. And in an earlier part, we also worked out the angle theta as 11.3. And we can stick with those two numbers for the next part, and the next part is part C. After we found the parametric equation, so let's just repeat part B, because we're going to need that. So part B was to find out the parametric equations for the plane's motion. So we had x equals, and then we substituted in the v is 50 and the theta is 11.3, and we ended up with 49.0 times t. The y, again, we did the same substitution. V is 50, theta is 11.3. If you substitute that into there, then that works out on your calculator as 9.81 t. So today's question is part C, and the question is, at t equals 10, after 10 seconds, how high has the plane climbed? What is the vertical height? The vertical height is given by the y equation, and we can use the y equation after we've done the substitution. So let's take a copy of that y equation, and we can just use that to work out the vertical height. The time is 10 seconds, so that works out as y equals 9.81 times 10, which is going to be 98.1 meters. Okay, and the next part is to say, show that the plane's motion is a straight line. Show that the plane's motion is a straight line. And this is a really good example of a question where you know the maths, but because it's presented in words, then it doesn't quite click. But if you think of all the work you've done where you've taken two parametric equations and you've turned it so that you've changed it around so that it's a new equation with y equals something something x, then that's all we need to do here. That's all this question's asking, is that if you were to change around the equation, so you have y equals something x, then would that be an equation of a straight line? So let's take the two equations and let's see if we can change them around a bit. We've got the x equation and the y equation. Let's start with the x equation and just rearrange it for t. So we've got t equals x over 49. Now we've got t, we can then substitute that into the other parametric equation. That's the y one. So let's take the y one and let's substitute in there that the t can be substituted for x over 49. So I've got y is equal to 9.81 times x over 49. 9.81 divided by 49, that's going to give me 0.2. So I can replace this with 0.2 times x. And then if you think about 0.2 times x, what kind of equation is that? Then you can hopefully remember that it's simply following the format of y equals mx plus c, with the c being 0. So we can take that out. So we're just left with mx, and that format is a straight line where 0.2 is the gradient. Okay, and that's enough to show that the plane's motion is a straight line. Good. And one final part on this question is that the original equations had the domain t is greater than 0. Why would that be unrealistic? And the answer here is simply that if t carries on being greater than 0, then that means that the plane is going to keep on going across and it's going to keep on going up. And that's unrealistic because sooner or later you would expect the plane to stop going up. It would have to, the height would have to settle down at some point. Thanks for joining me today. We'll do more in the next lesson on a new chapter for differentiation. Assalamu alaikum wa rahmatullah. Peace be with you and the mercy and blessings of God.